And this is going to help you get a really good basis for what we are going to be doing later next week on stoichiometry. So, do you have a periodic table out and handy? Do you have notes? Do you have something to write with? And do you have a calculator as well? Get all that stuff out. And let's talk about number 1 and 2. So, what do you have for number 1? Once you guys are ready, you can type in your answer for number 1 in the text box. Cool. Yep, 2 moles of calcium is fine for number 1. And then what about number 2? Once you guys get the answer for that, answer as well and include your units too. Cool, 4.25 grams is lovely. All right, moving on. So can you guys, how about let's split this up? So Aiden and Selena, can you guys answer what the molar mass is of these 2 reactants? And then Jess, Blake, and Melanie, can you guys do some of the products, please? And then once you have an answer, just type it in. All right. Oh, cool. So let's talk about how we're going to calculate out the copper. Let's see, try. All right, cool. So yes, you would, if you were calculating 3 moles of copper, you would multiply the mass of copper 63.55 by 2. But this is the tricky part about molar mass for balanced chemical equations. You just use the molar mass. You don't yet take into account the coefficient in front of it. So the molar mass of each reactant, so copper is going to be 63.55 grams. And for HNO3, so now we can start fixing all of our other ones. So if copper is 63.55, HNO3, we don't multiply by the 8, we just do the HNO3 alone. Cool, so HNO3, I got a 63. Do I have any more 63s for HNO3? I think there's a decimal in there somewhere, but it's going to round to 63 around there. Let's see, 1.01 plus 1401 plus 16 times 3. Yeah, 63.0 is fine for that one. All right, cool. Great. And then the products, we would do the same way. So we would do 1 copper, 2 nitrates, 6 oxygens for figuring out the copper nitrate. NO is just going to be nitrogen plus oxygen. H2O, we've done that a bunch. That's going to be 18.01. Great. So moving on. What is our agenda today? So we warmed up. We're going to do a little bit of stoichiometry. We're going to do a little bit of practice, and then we're going to have an exit slip. All right, so this is our mole triad. We have done a lot of stuff in the bottom part of this. So we've done a lot of practice going from mass to moles, so grams to moles. We've also done a lot of practice going from moles to number of particles. And what we're gonna do later on is going from moles to volume of gas, but that's something that we're gonna learn later. Right now, we're just getting more practice going from mass to moles to particles and back and forth. All right, so write this down, stoichiometry. It just means an advanced form of chemical reaction math. All right, and why is this important to chemists? Let's talk about baking for a little bit. If I went to the store and bought a 50-pound bag of flour, but only 6 eggs, you wouldn't necessarily think that I was going to use up all of the flour because I have such a limited amount of eggs, right? Scientists think in the same way. When we order reagents for our reactions, we want to make sure we're ordering the proper amount. We don't want too much extra of one specific reagent, and we want to make sure we're being efficient with our ordering. So this is one way that stoichiometry helps me. I mean, I use stoichiometry all the time to try to figure out what I'm going to order for you guys for our labs. All right. And as we're going through, anyone who wants to join into the chat, you can ask a question at any point. I will get to it as I come to them. All right, so cookies. Everyone loves talking about cookies. If Josie has 4 eggs and an unlimited supply of flour, sugar, and butter, how many cookies can she make? Type it in. Oh, blast. Can you guys still hear me? Oh, 48, there we go, good. Yes, 48, 48 is good. So what you guys did in your head, I'm gonna write out on here, and I want you guys to write it out in your notes because when we go to the chemistry and the chemical part of it, you'll be able to compare the two. All right, so what are we given? We are given 4 eggs. What do we wanna figure out? How many cookies we can make. So we're gonna start out with 4 eggs, and we're gonna put that over 1. And how many eggs to cookies? This is what's called our ratio right here. So we need 2 eggs to make 24 cookies, and that is going to be 48 cookies. What unit cancels out? Oh, yay, Blake, good. What unit cancels out is going to be eggs. So that gets canceled out. Cool. What's next? If Josie has 1 egg, how many cookies can she make? Okay, I got 1 for 12. Cool. So this is going to look like 1 egg, and we're going to star what we're given, and we are going to box what we need. So we have 1 egg times the same ratio as before, right? 2 eggs to 24 cookies. And that is going to equal 12 cookies. All right, cool. So again, pretty basic math, and you guys can follow along with that pretty easily. All right, next. Now, what about this one? Read the whole question before you answer. All right, I'll keep on going once I get a couple more answers. Cool, cool. All right, so 72, excellent. So I'm going to do the same thing. I am going to star what I am given. I'm going to box what I want to find. And so I have 3 cups of sugar, right? Over 1 times, and then we're using our ratio. So it's 1 cup of sugar to 24 cookies. And that is going to be 72 cookies. The unit that I'm canceling out is going to be cups of sugar. Great. All right, so chemical reactions are very similar to cookie recipes. And some of the differences are that in the future, we're going to be using elements like copper fluoride and compounds instead of just eggs and butter. And we're going to be using very specific numbers too. So 22.99 grams of sodium, because that's the molar mass of sodium, instead of whole numbers. So just be used to the decimals in there. All right. So now we are going to start doing our actual stoichiometry problem. So I'm going to walk you through this first one. So again, I'm going to star what we're given. Oops. Star that. I am going to box what we want, how many moles of water. So write this down in your notes along with me. So we have 3 moles of copper. We're going to put that over 1. And this is a pretty straightforward one, because what do you notice about the moles of copper that we were given and the balanced equation? They are the same. So 3 moles of copper, I can just look at this balanced equation and say, all right, if I have 3 moles of copper and a ton of nitric acid, I'm going to be able to make 4 moles of water. I'm going to write it out just so you guys know how to do that. So 3 moles of copper. Then I'm going to use my balanced equation to get the mole-to-mole ratio from moles of copper to what we want, which is moles of water. And what is the ratio of copper to water? So you can type that in. What's the ratio of copper to water? Yeah, type it in if you can. Cool, I got a 3 to 4. Anyone else agree with that? Cool. All right, so we have 3 moles of copper to 4 moles of water. Great. The moles of copper are going to cancel out, and you can even cancel out that 3 and 3 too. So we're going to get 4 moles of water. Excellent. All right. Next up, what about 6 moles of copper? Do we really even need to write this down? Maybe not. So if we have 6 moles of copper, how many moles of water can we make? Type it in. Cool. I got a bunch of people saying 8. That's exactly right. So what you did in your head is what we can write out as well. All right, cool. Let's move on. Now, if we have 6 moles of copper, how many moles of copper nitrate can we make? Next one, type it in when you're ready. Cool. So this is going to be 6 moles of copper. Copper nitrate. We got some 4s. All right, let's see this one. So we have 6 moles of copper, which is what we're given. All right, and then we have how many moles of copper nitrate, right? So 6 moles of copper over 1. And then we're going to do our mole-to-mole ratio, which is going to be moles of copper on the bottom. What do we want to make? We want to make moles of copper nitrate, NO3. Cool. What's the mole to mole ratio for copper to copper nitrate? That is going to be a straight 3-to-3 ratio or a 1-to-1 ratio. So this should be 6 moles of copper nitrate. We can cancel out our units. Does that make sense? Were some people confusing that, the NO with copper nitrate? Yeah, got it. All right, cool. Great. So we cleared up that. So what's up next? All right, so now we are not going from moles to moles anymore. We are going to try our first one from grams to moles. So this is going to be very, very important to write in your notes as well. So let's start this one out. I'm going to star what we're given. I'm going to box what we need to find. All right, so let's do this together. So I'm going to start off with 126 grams of copper over 1. All right, and first I need to figure out how many moles of copper I have. So we need to cancel out the grams of copper and go to moles of copper. Do we know how many grams of copper are in 1 mole? And once you know that, type it in. All right, cool. And where did you get that from? Cool, molar mass periodic table, excellent. And that's exactly what this is. So right here, this is gonna be the molar mass, and you get it by using the periodic table. Excellent. All right, so next, we are going to do our next step, which now that we have moles of copper, grams of copper, we have taken care of. Can we go from moles of copper to moles of copper nitrate? And we can using the balanced chemical equation. So this is where the mole to mole ratio comes into play. So using the numbers in that balanced equation, what is the ratio of copper to copper nitrate? And you can type it in. All right, so this one is going to be moles of copper right here. That comes from right here. So 3 moles of copper to 3 moles of copper nitrate up there. Cool. Great. So now we have canceled out moles of copper. Are we at the unit that we want according to our question? We are. So basically 3 and 3 also cancels out, right? So what is the answer to this going to be? So type that into your calculators and see what you get. Okay, we got a 1.98. Cool, what are the units on that? Cool. So 1.98 moles of copper, oops, nitrate, NO3. I'm sorry about this pen, folks. Copper nitrate, that is exactly right. All right, again, when you guys have questions, just let me know. All right, so I want to highlight the steps that we have taken here. So our first step was molar mass. Our second step is called the mole to mole ratio. And that is from our balanced chemical equation. Write this down in your notes. Ooh, my handwriting on here is so bad. All right, cool. I'll give you another 10 seconds and then I'll move on to the next one. How are we doing on time? All right, another 10 minutes. All right, let's clear that. Okay, so these are the basic types of conversions for stoichiometry. One-step problems are from moles to moles, so that is going to use the balanced chemical equation. Two-step problems is the type that we just did, from moles to grams or from grams to moles, where your first step is from moles to moles, your second step is from moles to grams, or the one that we just did was the opposite. The first step was grams to moles and then moles to moles. And then the third type of problem is going to be something called your grams to grams, 3 steps. So the first step, grams to moles, the second step, moles to moles, and the third step, moles to grams. Cool. Again, when you guys have questions, just type me a little note. All right, so I'm gonna go through another problem with you folks. Here we go. These are the steps for stoichiometry problems. So you wanna star what you're given, you wanna box what you need to find, which is what I've been doing. Usually you're gonna wanna convert what you're given to moles. You're gonna use that mole to mole ratio from the balanced chemical equation. And you also wanna make sure your units are canceling out. So those are the basic steps. Cool. I'm going to move on. If you guys want me to go back, just type me a little note and I'll go back for you. All right. So this is the major 3-step problem that we're going to do together. All right. So let's begin with this one. Okay. So what are we given? 126. What do we want to find? How many grams of copper nitrate can we produce? Cool. All right, so I'm going to start with 100. Ooh, that's kind of light. How about let's do this one? No, I don't want that either. This guy. Okay, so 126 grams of copper. All right, that's over 1. So if you look back at your notes, this is going to be a grams to grams problem, 3-step problem. What do we want to do first? Convert to moles. And we can do that grams of copper to 1 mole of copper. We look on our periodic table. So take a look. What's copper? 63.55. All right. And now our grams are canceled out. What do we do next? Our mole to mole ratio. So we have moles of copper and we also need grams of copper nitrate. So I want to go to moles of copper nitrate first. All right, now I'm going to look at my balanced chemical equation. I see that copper right here is 3, so I'm going to put that 3 next to moles of copper. Copper nitrate up here is 3. I'm going to put that right there as well. What can we cancel out? We can cancel out moles of copper. All right, next up is going to be our final step, which is converting back to grams. So copper nitrate right here. So what amount is going to be in 1 mole of copper nitrate? So why don't you guys work on that? Tell me the molar mass of copper nitrate. Once you have that, type it in the chat box. Cool. We got one answer for 187.56. Can I get someone to confirm? I was gonna say, can I get an amen? All right, cool. So we have two saying the same thing. So let's put in 187.56. Cool. All right, let's do that. So we have now canceled out our final unit. We are left with grams of copper nitrate, which is exactly what our problem asked us to find. Double checking all of the units, they look pretty good. And we can also cross out these threes. So be careful of order of operations here. So you're going to want to go 126 times 187.56 over 63.55. All right. Once you get that, let me know by typing it in. Cool, I got a 371.87. And let's be exact about this. Let's figure out sig figs and let's put in a unit. Cool. Yeah, so the difference between 371 and 372, I'm not gonna really worry about that difference, but yeah, if you got around that, so 371 grams of copper nitrate. Do you guys remember the triple threat? We have a number, we have a unit, and we have the chemical. So number, unit, and chemical, and then we are all set. That's excellent. Excellent, excellent. This is the hardest type of problem that you are going to see in the future. So if you followed along with that and got into the mindset, excellent. Now the next step is for you to practice on your own using the book problems. Cool. All right, I'm going to clear this off in 10 seconds. So if you need to copy anything down, you can. Okay. And next up, just a quick exit slip. How about, let's split this up. So Aiden and Blake, can you guys do A? Selena and Jess, can you guys do B? And Mandy and Melanie, can you guys do C? Ooh, cool. And Jess, thanks for screen recording this. I am also I figured out how to record it, so I am recording it right now, and I will be posting it to Google Classroom so that everyone can look at it as well. So excellent. You can actually comment, Jess, on the post that I'm gonna make, and if you wanna include your screenshots, that would be great for folks to share out. All right, so once you have your answer, write in the text box A, and then your answer B, and then your answer C, and then your answer. It doesn't have to be in any order. So whenever you get that answer, just type it in. Okay, A. Oh, A, you want the molar mass, Aiden. So what's the molar mass of H2? There you go. Blake has it. And Blake, what are the units on there? Cool. So let's do a drawing. Okay. So this is going to be 2.02 grams of H2. Excellent. We have any B's or C's coming up? I'll open up to everyone. So anyone who wants to answer B or C, just write down the letter and then what your answer is. Remember those units. Okay, so for, let's see, 2 moles O2. For this one, okay. Okay, so for this one, let's box what we need to find. We want to find grams of H2O, right? So we need this at the end to be grams of H2O, which it is. So working backwards, our mole to mole ratio shouldn't get us to O2. Our mole to mole ratio has to get us to H2O. So this needs to be moles of H2O right here. There you go. And then 2 moles of H2O. Excellent. So this, if you were getting confused about this, the unlimited supply of O2, that means that you have tons of oxygen available. It's not going to limit your reaction at all. So what we need to pay attention to is the hydrogen and the water for this question. All right, cool. So we got B, the done. And now, remember how we used to do those problems? Like I always put in the unit first. So figure out what unit needs to be canceled out and see if that can help you fill in C. Cool. So I agree with moles of H2O for sure. And we're not going to use 2 moles. We're going to use we're going to use 1 mole. Okay, so why is this? Remember from before, let's see, we have 3 steps right here. We have step 1, we have step 2, and we have step 3. So this middle step right here, step 2, the 2 comes from the water. And then let's do green. This 2 right here comes from there. So the mole to mole ratio comes from the balanced chemical equation. And for step number 3, that's just going to be molar mass. So steps 1 and 3 are going to be molar mass. You just take 1 mole of whatever substance you're dealing with. The middle step, step 2, you're going to take the mole to mole ratio from your balanced chemical equation. Okay, that's all I have for you folks today in terms of chemistry. But can you guys tell me, have any other teachers been doing these live lessons, and what kind of platforms are they using? And have you found them helpful at all? Okay, cool. Was this helpful? I know I still need to work out like some of the quirks. Cool. Cool. So next week, we are going to get into some more challenging concepts. So I'll pop in a live lesson or 2 next week as well. And I'm also going to try possibly using another platform. This works out okay. I'm lucky because I have a stylist, but you know, improvements. Great. Well, folks, thanks so much for joining me. Please reach out to my email if you need any help. I am going to be posting this on Google Classroom. Let's see. I'm gonna actually try stopping the share, speaker view. All right, so I'm gonna be trying to post this on Google Classroom, and let me know what's working, what's not working at home, so we can all be in this together. All right, thanks guys, bye.